Alright, this is me finally turning this in because I thought that I couldn't, but we're doing it. Alright, I'm just gonna do one audio file. I hope that works. I don't really feel like recording three and then combining them all together. I'm just gonna do one of the whole slideshow. Okay, so for lesson one, some key terms that were on the notes. So the x and y intercept, where the function crosses the given axis, not axis. For the y, it's when x equals 0, because if it's crossing the y-axis, it's when x equals 0. Wow, I'm so good at explaining things. And then for x-intercept is when y equals 0, so domain and range, it's all real points on the given axis. For range, it's on the y-axis, so all the real points up and down. For domain, it's all the real points left and right. So for range on this graph, it starts at 5 and goes up infinitely from up and down. And then for domain on this graph, it's negative infinity to positive infinity, because this function is has infinite x values. And I made a little, oh shoot, I went to the next scene. Can I turn this thing off? Okay. I don't know how to turn this thing off. We're gonna get out of this. So we're gonna exit because I don't know how to do it like that. Okay. So vertex, where the line peaks. So yeah, but I made this little visual here and some examples of domain and range. For this, using a screenshot tool that I have on my computer, I can just go like this, and I can draw all over it. It's pretty great. Okay, so then lesson 2, I think we can, oh shoot. I think we have to go back into present for this one, but we're going to have to go back out of it for the next one. For discriminant, the equation that gives you the number, that gives you information about the roots of a 0 and a quadratic function. I probably should have given some examples for this, but so when you plug, if you have the quadratic equation in standard form, and you plug the b here and then the AC, if you plug the values into this equation, then you'll get a number. And if that number is negative, then it's 2 complex imaginary roots. If the number is positive, it's 2 real roots. And if it's 0, correct me if I'm wrong, I think it's 1 imaginary and 1 real root. Because, I mean, I hope that's right. I think that's right, because I haven't done this unit since before winter break. But yeah, so that's a discriminant. Imaginary number is a number that when squared gives a negative result. So they can't really have like a number for that, so they have I. So I squared is -1. Vertex form. Vertex form of a quadratic function is given by f of x equals, that, where hk is the vertex of the parabola. I didn't actually realize that until reading this, because I didn't do the notes for lesson 2. We're not going to talk about that, but I think it makes it so much more useful, because it's so much easier to move a quadratic function when you have the points of the vertex in the equation, which makes this really helpful, especially for, oh wait, the thing went away. Oh, I could have just done that. I could have just gone off of it. Look at me being intelligent. Okay, yeah, but it's really helpful. It's really useful for translations, which can be most easily done when the function is in vertex form, because the vertex is just hk. So if you change h, you change the x value of the vertex. If you change k, you change the y value of the vertex. It's really simple. It's so helpful. Okay, yeah, but the secant is a line that passes through 2 points, and a tangent's the one, or just, it's a line that passes through 1 point. So an intersection is the point where it crosses, and then that's the translation. And then that's it. I'm done. Well, I made this little visual to try to explain the intersection secant stuff. But yeah, we're done. Woo! Finally got to turn this in.